So this will be a short video, but just going to point out that I now have my IDE interface running, and I'll just pull these cards out for a minute. And so this is the simple IDE interface that I am using. And right now I'm running a 32 gig SanDisk CF card. So that CF card I'm just placing into, really it's a CF to IDE adapter, and that connects to this IDE interface that then goes to an ISA bus onto my system. So pretty basic as far as functionality, and I've had previous videos on building this, and I believe I have the schematics on my website if anybody wants to see exactly, what the simple circuit looks like for this. But I've got that in here, and on the CF card I have formatted it, partitioned it, formatted it, and installed FreeDOS, and I did that on a different computer. So I took an old system, plugged in the CF card, and essentially partitioned and formatted and installed FreeDOS. And then of course I got my video card, which I'm running right here in this slot. Maybe to get this card working, there were a couple things I did, and I'll walk through that here briefly. And so one of the first things I had to do over here on my PC, let me pull up my PSOC. So on my PSOC here, I have this project for my decode PSOC. So that's this number 2 PSOC on my build. And it's been doing things like my ROM and RAM, whether or not it should be chip select or output or writing for my RAM as an example. And I was also doing my decode for my VIA and my PIC. Well, I added in IDE to this, and really there isn't much decode here to talk about, but let me just walk through this. So previously I had my, let's just start out with the VIA. That was the first one I did, and I said, okay, if the address 7 is a 0 and address 6 is a 1, and I am doing I/O according to the processor, then go ahead and enable the VIA. And that was this up here to give me my SPI functionality for a lot of the other communication I'm doing in the system. And that basically corresponded to certain address ranges, this pattern that you're seeing here. And then later I added my priority interrupt controller, and I chose some addresses for that, and here's the pattern for that. And when that is true, it then brings this activate line low to basically turn on my interrupt controller. So that would be this chip right here. Down here at the bottom, I've got my VGA. Again, I'm looking for a certain pattern that essentially is this address A0 through AF on my IO range. And so when I write IO to that, it comes to the registers. And here on this VGA card, I have this RAM basically that is being used to output. And I've got a couple of things. I've got a PSOC that basically does all the reading of the RAM and sends it out through all of this circuitry to the VGA connector. And then there's also a PSOC for decode. But besides that, I do have just some plain old registers on here. So I have some registers that I built in so that I can control which frame is active and things like that. Well, that functionality needs an IO address because I'm doing that through IO to modify the register. The video memory I access as an A0000 address for a 64K segment, and I can cycle through 2 meg worth of those segments to populate the video memory, but I need this IO register, and this is the address for that. And when that happens, previously I really wasn't doing anything on my PSOC because the video card does all the decoding. And I should clarify, the PSOC on my computer that does the general address decoding, this one that I'm in right now for this project. And since all that intelligence is on the VGA card, I don't need to mess with it on the actual 386 or 486 board here. And then with the IDE, it's the same thing. When I come to the IDE, it basically is configurable. I have some jumpers here. Basically, there's 3 jumpers that let me specify, what address am I going to set this to. And that would be this A7, A6, and A5. So I've set it, I don't know if you can tell in the video, I've set it to 100. And that essentially is setting those 3 addresses, and that's how I then do the rest of my logic here. Now, ideally, I would change this card a little bit. Let me get this back in here. You know, I'm using those 3 jumpers to help me set this 1, 0, 0 here. And then if that is the case, then I know it's enabled. And again, the logic to enable it is on the card itself. And I'm just having to make sure I use unique addresses here that don't step on each other as far as these bit patterns. And as I've mentioned before, I should technically put in A8 on up and make sure those are all zeros to make sure I'm not, for example, using a higher address. I believe you've got 64K of addresses for I/O, and make sure I'm not using something like in byte, the second byte. This is all the lowest byte that I'm using to do my addressing for I/O, but at some point I'll probably use the next highest byte. But one thing I did do in here is I added, and I had this in my design, so if I open up my Easy EDA for a second and get that flipped over to this monitor, if I look at my design on this top board up here, I do have this PSOC number 2 that's doing all of my decode. And in that, I did connect in this BS16. So it's an active low, and basically when I'm doing that, it's telling the system I'm doing a 16-bit type of activity instead of a 32-bit activity. And being that I went to, quad, that I'm using quad RAM, that I want to do in 32-bit. But anytime I'm doing any I/O to these cards, I technically I'm doing 16-bit I/O, and I want to make sure I tell the system that. So that I'm going to use this signal, and here's the logic that's connected to that signal. So I'm coming in here and just simply saying, if the interrupt controller is active, bring that value, that 0, into this AND gate. Or if the VIA1 is active, I'm going to look at its signal, and that would be a 0 if it's active or a 1 if it's not. And same with the IDE and the VGA. So even though I'm not doing any technical decoding here to enable the IDE interface or the VGA registers, I'm setting this up so that I know when I expect those cards to be enabled. So if any of these are enabled, they would be active low, and then this AND gate would bring out a low. So all of these would have to come in as non-active high for this to send out a high. So if I'm not doing any I/O to any of these devices, this is going to be a 1, which means it's not asserted, it's not active. If I use any of these 16-bit devices, because I'm basically treating these all as 16-bit. Now, most of these, of course, I'm only writing, like if I go to my pick, I'm only writing a byte, so it's actually only 8-bit. The VIA is 8-bit. The VGA registers would be 8-bit. And actually, I have to go back, and maybe I would look at that just for a second. So if I come over to my video card, I can come down here and look and see, oh, this would be an old video card. Here's the one I'm looking for. So down here I have these registers, and actually I did set it up as a 16-bit register. I'm not using the second byte of it yet, but I do have 4 bits. But anyways, this one is a 16-bit as I look at that quickly. So, when I come into this, I have the VGA as a 16-bit register that I'm using. I have my IDE, which if I pull up the schematic for that quickly, when this is being used, basically these would be the 2 slots that I'm accessing. But I can look at this and I can see that I am using data 0 through data 15. That those data lines are connecting over to these data lines. So off my ISA edge card, so the edge of the card. So basically I'm doing 16-bit there. And so I've got 2 16-bit I/O devices, the IDE and the VGA, and then technically these others are 8-bit. And if any of them are enabled, then I drop this line here low. And I did notice I had to do that without this. It seems like it was running fine before with the priority interrupt controller and the VIA and the VGA, but once I got into IDE, and I think part of the problem is the way that I have this IDE card addressed. And what you'll notice is that If I go back to the IDE design for a second, and I didn't want to change this, so I just am rolling with it. I am using basically address lines from A7 all the way down to A1. And I should only be using address lines from A7 down to A2. That should be my boundary. So I probably should move the I/O address of this card to start at A8 and work down to A2. So shift all this stuff up a bit on the address line, and then leave A1 and A0 open so that the processor stays on the double byte boundary. So I'm not using the bottom two address lines of A1 and A0 for my decode or for my transfers. All transfers should happen on a double byte boundary. So A1 and A0 should always be 0. But this card was not set up that way because I built it for my 286. And as I went to the 386, I wasn't sure if I would have to actually move that over, but I have not had to. So the coding that I'm using is working like this, but it probably isn't ideal. I think ideally I would come up higher on this. But what I did notice is that if I wanted to use it like this, A7 down to A1, I did have to put in that activate of this other line. And so let me pull that back up. This right here, this BS16. So this was the additional logic I put into my PSOC, and then I plugged my card in, and then of course I had to update my assembly. And so this is what my assembly looks like at this point real quick. So as I get into this, I come down here and I just make a note of which I/O addresses I am using at this point. So my PIC, a placeholder for my 486 and what was that, 22 and 23. I believe is what I was going to need to use there to access the registers on the processor itself. This is so that I can do cache management as an example. There's the 1K of cache on the 486 DLC. But then I have my IDE interface and my VGA, so I just got those all noted real quick. And then I come in here and basically doing a lot of stuff you've seen in previous videos, but as I get down to the bottom of this, I do call this identify drive, and basically that just goes out and tries to pull data off the drive to understand some of the configuration about it. How is it configured? And then with that, let me just jump to that and show you that. And so what this does basically is comes in here and I come out and I'm accessing one of the registers. There's a couple of these that I have to access, and you'll see these IDE reg. Those are different registers on that IDE device. And I'm trying to pull out information, and I've got some delays in here that I'm working with, but I eventually pull out all this information, bytes per sector, cylinders, heads, sectors, how is it, what is it default to, what's the current value. Maybe I do some calculated values if I wanted to make adjustments because of limitations in some of how different systems read those numbers. But that's all information that I grab, and I put it into very specific spots in memory, because later other things like FreeDOS are going to look at some of that information. But then I get down here and I jump to a procedure I have called load bootloader. And in that's essentially where I get things ready to load up FreeDOS off of the CF card. And so I've got some code here, and I've talked through some of this in previous videos, but basically I'm saying, okay, I need to take some information that's on the CF card and get it copied over into RAM. And that's what I do. I just set up all my essentially parameters. I want to do an IDE read off of the CF card. And this is just telling it, what do I want to read? Where do I want to place it? And I want to place some stuff off the CF card at a very specific address in RAM. And then at some point, I want to actually jump to that very specific address. So when the system turns on, I quick read some information about the drive. I get that populated into some spots in memory. I might output it in my debug window. But then I turn around and say, okay, now copy. I got really this master boot type of record, and I want to basically copy it over. So I've got a master boot record, and there's also this DOS boot sector, two different locations on the CF card, but I get this pointed to the MBR, I get that copied over into RAM, and then I turn around and I jump to that. And before that, I do start my VIA timer. So I'm using this VIA as a timer that FreeDOS will leverage when it needs to compare times, like how long something has taken, or to check that there's a countdown or something like that. So with all of that, FreeDOS is on on this CF card, which is in my IDE interface, plugged into an ISA slot. This is the code now. So when I get to this jump, I'm handing off to FreeDOS. So FreeDOS will do its load, basically, and try to get all the way up to the point where I'm running or loading the command processor from FreeDOS, FreeCom, and then hopefully things at that point I can do whatever I need to do in FreeDOS. And as a reminder, if you've not seen my older videos, there's a lot of graphic support I do not yet have for my video card. So for FreeDOS, I'm really only using a text-based only. I'm not really doing anything with graphical, other than my own graphical routines that I've been working on. I'm not supporting any of the graphical apps in FreeDOS yet. That's stuff I need to work on. So maybe with that, I can try to fire this up. I will turn on my system and just kind of show you where I'm at with it. At this point, I have FreeDOS booted and appears to be working. Now, quick note, I am running this system at a 12 megahertz clock 2, which means the processor is running at 12 megahertz, and then my ISA clock is running at 6 megahertz. If I flip this switch, I can double that, and right now what I would expect is that when it gets to the CF card I/O, it will stall out at that speed. So most likely I have work to do, either to modify wait states for this specific address, or update my code and add in possibly delays at certain locations, because I think most of it is that I'm just trying to access that CF card too quickly. That's where I'm going to leave it. And in my next video, I'm going to talk about maybe next steps I'm going to take on this build.